Hello guys, photography is the art of light. So every photographer should understand how the light in photography is working. So in this video I am covering two major concepts in light. One is lumen and other is lux. These are the two major concepts which we need to learn in photography. Whether you are a beginner to grab your basics ideas or you are a pro just to refine your skills, this channel is for you. Here we will be covering both theory and practical side of lighting. In this video, I'm mostly covering the theory part of this lumen and lux. And get ready, comfortable, grab your camera. Let's learn how lux and lumen working in photography.
Lumens and Lux. In this topic, we would like to cover what are lumens, what is lux, a relationship between lumens and lux, and how to select light for your photography and videography. So, in this presentation, we will be learning the difference between lumens and lux and how to calculate them in various scenarios, understanding why lux and lumens are crucial for achieving desired photography results, and the factors need to consider while buying lights for photography, the practical examples with those lights. What are lumens? The definition says a unit of luminous flux representing the total quantity of visible light emitted by a source. This is very simple. This is the total light output from a source. Suppose you have a bulb in your house. If that bulb can emit 800 lumens, that is the total output of that bulb. You will get to know more about lumens when we are discussing the lux. What are lux? The definition says a measurement of 1 lux is equal to the illumination of a 1 meter square surface, that is 1 meter away from a single candle. This is the total light intensity per a unit area. So in this picture, you will know that we have a light source, which is a candle, and this candle produces a maximum of light output of 1 lumen, and we have a subject which is 1 meter square, and we place that subject 1 meter away from the candle. So the lux will be 1 in the surface. Suppose we have 5 candles here and each candle produces 1 lumen. The total lumen is 5 lumen. Suppose you are considering this as the source of light. That means that your current source of light will produce 5 lumen. If you are placing the 1 meter square, which is exactly 1 meter away from your 5 lumen source of light, then you will get 5 lux on your surface. Suppose if it's 1000 lumen, you will get 1000 lux. And the definition always indicating that the subject should place exactly 1 meter away from the source of light. What will happen if you place the subject exactly 5 meter away or 10 meter away or 1000 meter away? That we will learn in the next upcoming slides. Now we can learn lux of a natural ambient light. In this table, we will be showing the lux of direct sunlight, ambient daylight, sunset, sunrise, moonlight, night, and etc. So we'll get to know how much lux each natural ambient light is producing on a subject. So in this chart, we are explaining lux of artificial indoor lighting. For example, if a hospital theater have a 1000 lux on your subject, that means the bulb in the hospital theater which should produce a luminance of 1000 lux. If it's a family room, the bulb will produce only 50 lux. So this will help you to understand which bulb you should buy for a specific indoor lighting. This is mostly used by architectures, and in photography you can use this to identify whether you need to carry a light to the place. Suppose you are going to a hospital theater and you need only 1000 lux on your subject, you don't need to carry any extra lights. If you're placing your subject exactly 1 meter away from the source of light, suppose you are taking a family photo inside a living room, the light inside the living room is producing only 50 lux. That is not enough for your camera to capture. The camera will capture, but the exposure will be very less. So you need to bring your artificial lights to a living room to capture or to get 1,000 lux on subject face. Relationship between lumens and lux. So when we are talking about only from the photography perspective, we should understand that the photography strobes or the flash units are point light source. To understand the relationship between lumens and lux, we should learn this equation E equal to lux by d raised to 2. Inverse square law states that the lux decreases as the distance from the light source increases. Means if your subject is moving away from the light source, the light will decrease. We know that if your subject is moving away, the light is decreasing. That we know. So for this, we have an equation E equal to lux by d raised to 2, where d is the distance from light source and E is the lux at distance d. Suppose you have a strobe light which produces 10,000 lux per meter, and if you are placing that strobe light and your subject is exactly 1 meter away, you will get 10,000 lux on the subject. But in real scenario, it is not. We are not using the complete power of that source. So here we can consider we are keeping our subject 10 meter away from the light. 10,000 is the maximum lumens the light is producing, and 10 is the distance from the light to the subject. So this equation lux by d raised to 2 will give you the lux on your subject. So 10,000 by 100 will give you 100 lux. So if you have a light of 10,000 lux, and if you are placing that light 10 meter away from your subject, you will get only 100 lux on your subject. Now we can learn how to select a continuous light. If you are going to a online platform to buy a light, you will see a page like this. Now I am considering Amazon. You can see here the newer CB200 210 watt LED video light produce a lux of 90,000 per 1 meter. That means if you're keeping this light as a source of light and you are placing your subject 1 meter away, and you will get 90,000 lux on your subject. That's very high, right? So what we do is like we will use modifiers, we will use reflectors to control the lights. And also this description shows that in silent mode provides only 60-watt power and 30,000 lux in 1 meter. Suppose you are keeping this light as a source of light and your subject is 10 meter away from the light, you will get only 900 lux based on the equation we learned in the inverse square law. That is, the total lux produced by this light is 90,000 divided by the distance, that is 10 meter, raised to 2 is 100, equal to 900. 900 is the lux you will get on the subject. So when you buy a light for indoor, suppose you need 1,000 lux on the subject, your subject will be always maximum 5 meter away. So you know that 5 raised to 2 is 25, and you need 1,000 lux on the subject. So 25 into 1,000 is 25,000. So you need to buy a light of 25,000 lux per 1 meter. Based on your requirement, you can find the lux value and you can buy the lights based on that lux value. Now let's learn the lux at different distance on continuous lights. So this diagram illustrates the change in lux on your subject based on the distance. The 9,000 lux source per light is here, and we placed our subject 1 meter away from the light, and we got 9,000 lux on the subject. Suppose we are keeping subject 2 meter away from the source. In that case, we know the equation to find lux, which is E is equal to lux by distance raised to 2. So here the total lux is 9,000 and the distance is 2 meter. So 2 raised to 2, and the lux is 22,500, which is decreased 4 times. We increased the distance 2 times, but the light decreases to 4 times. See, this is the inverse square law teaches us. Now we can consider another example. Now our light source is still the same and we placed our subject 5 meter away. Now the equation changes like 90,000 lux divided by 5 meter, 5 is the distance, raised to 2. So the lux on the subject will become 3600. So if you are placing a subject 5 meter away from a light source which produce 90,000 lux, you will get 3600 lux on your subject. And if you are again increasing the size to 10 meter, you will get only 900 lux. I hope you understood how the light is decreasing when increasing the distance. How to buy speed light? So for example, I considered Godox AD200 Pro, which is a popular portable flash unit most of the photographers are using. Here we are considering gauge number. You know, the Godox AD200 Pro is coming with two flash head. One is speedlight, one is bare bulb. The gauge number for these two are different. It is 52 meter at ISO 100 for a speedlight and 60 meter at ISO 100 for bare bulb. The gauge number is calculated using this equation, distance dash f number. The gauge number 60 means the Godox AD200 Pro will illuminate a subject up to 60 meter away when ISO set to 100. That means your camera ISO set to 100 and your f-stop value is 1, and if the distance is 60 meter, you will get a 60 gauge number. So 60 into 1 is 60, right? This is what we explained here. If the gauge number is 52, that means in full power and ISO 100 and the f-stop value 1, it can illuminate a subject which is placed 52 meter away from the light. Okay, let's consider another example. Suppose your gauge number is 60 and your f-stop is 4, then your AD200 Pro light can illuminate the subject which is placed up to 15 meter. It cannot illuminate the subject placed on 20 meter, 60 meter, 30 meter, whatever it is. It can illuminate subject which is placed up to 50 meter only. So when you increase the f-stop value, the distance will decrease. So this is a question for our viewers to find. Just comment the answer in the comment box. What if you want to bring our subject to 7.5 meter away? Would we reduce the half power? Yes or no? Or what is the equation to calculate the distance based on the half power of the speed light? This slide showing the distance speed light can illuminate based on the f number. So here you can see the camera and the flash with the gauge number of 60, and we are keeping the ISO at 100 always. In all the pictures you can see the ISO is 100, the gauge number is 60. That means we are keeping the flashlight at full power always, but we are changing the aperture values. Now if we are keeping the aperture value as 1, the flash can illuminate the subject 60 meter away. If we are increasing the f number to 4, it is significantly reduced to 15 meter. And if you are again increasing the aperture, it will reduce to 1.8 meter. That means if the flash is still in the full power, we are increasing the aperture from 1 to 32. It can then illuminate the subject with a distance only in 1.8 meter. What if we increase the ISO while using a flash? If you moved ISO to 400, the gate number would also go 104 or 120. So 104 is, suppose your gate number is 52 at 100 ISO. If you are increasing the ISO to 400, it will go to 104. And if your gate number is 60 at ISO to 100, if you are increasing ISO to 400, your gate number will increase to 120. Every time multiply the ISO by 4, this will double the gate number. In this chart, you will get to know that at ISO 100, we have a gate number of 52, 400 we have 104, and 1600 we will get 208 as the gate number, 6400 your gate number become 416. So till here we haven't explained about shutter speed. We talked about ISO, we talked about aperture, we talked about the light power and everything, but we haven't talked about the shutter speed, because shutter speed does not affect the amount of illumination on the subject from the flash. Shutter speed will affect the amount of ambient light collected. So shutter speed doesn't have any role in lighting. It will have a role only in the ambient light. This diagram explains distance speedlight can illuminate based on the ISO. So in the previous diagram, when we are increasing the aperture, the distance was reducing. But here we are keeping the aperture same and we are increasing the ISO. So you know that at ISO 100 at f value 1, we were able to illuminate subject at a distance of 60. We saw it in the previous diagram. But here we are now at ISO 400 and the flashlight is still at the same power, full power. We are using the aperture 1. The flash can illuminate the subject at a distance of 120 meter. And now again I am multiplying the ISO with 4. Now it's big 1600. Now I can illuminate a subject of 240 meter. Here you can see if I am multiplying ISO with 4, the distance is doubling. So 120 become 240, 240 become 480. Here you can see 1600 is multiplied with 4. Now the ISO is 6400 and the F value same, the flash power is same, everything is same, but the distance is increased to 480 meter. Now I hope you understood how the lux and lumen are working and how the continuous light and the speed lights are working, how to purchase a speed light and a continuous light based on your requirement. Feel free to comment if you have any queries. If you like the video, please like, subscribe, and enable the bell icon. Thank you.